Hi class, this is 7.3, use similar right triangles. So our first theorem here says if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So we've got two similar triangles. When we draw in this, if I've got this right triangle right here, and I draw from here at a right angle straight up, that right there is called the altitude. Right there. That's my altitude. So my first example here says identify similar triangles in the diagram. So in order to do that, we need to redraw them. So I'm going to start by redrawing my smallest triangle. I'm going to draw this smallest triangle first, and here's my right angle. And as I do that, I'm going to make sure I have the same orientation. I'm going to put my right angle here on the left. And at that right angle, I have the point J. Along the shorter side, F comes up here, and G goes over here. My next triangle would be this medium-sized triangle, and here's my right angle. Got my right angle right here, and point J is at that right angle. Along the shorter side, this is a G, and along the longer leg, this is an H. And then the last triangle I have is my large triangle here. So I'm going to redraw that. I'm going to put my right angle right over here. And point G is at that right angle. And F is along the shorter leg. And H is along the longer leg. So now I can write these. I can write them as similar triangles. I'm going to go along my short leg. I'm going to put my right angle in the middle and then along my long leg. So this would be triangle FJG. Triangle GJH, and triangle FGH. So I need to know that corresponding vertices are in the same location. So pause it and try the next one on your own. Okay, in this next problem here, let's make sure that you drew them correctly. So my small triangle with a right angle, this would be NPL. My next size triangle, my middle size triangle, here's my right angle, and this, along this triangle, I would have L, and then P, and then M. And then my larger triangle, along my larger triangle, I would have an F, and then a G, and then my H. So to write these out, I would have triangle NPL is similar to triangle L, whoops, that should be LPM, and that's similar to triangle NLM. Okay, this next one, it says find the length of the altitude to the hypotenuse. So in my example here, says the following picture represents a cross-section of the bleachers of a stadium. It shows a drain pipe, segment BD, so right here, that leads from the seats to the inside of the stadium. What is the length of the pipe? So we're looking for what is this length right here. So we're going to start by identifying our similar triangles, and we're going to find the value of x, knowing that these two triangles are similar. So let's first draw our three triangles. Let's start with our smallest triangle. So my smallest triangle, I'm going to have my right angle here, and it looks like my right angle has a D here, and that B is along the longer leg, and so this would be point A up here, and then I do know the hypotenuse, that's 20 right there, and this longer leg is X. My middle-sized triangle, let's draw that right here. So on this triangle, here's my right angle. And along my shorter leg, this right angle has a D, and along the shorter leg, this would be point B, and then along the longer leg, this would be point C. So this has X as the shorter leg, and as the hypotenuse, we have 30. And then along my largest triangle, got my right angle here, that's at point B, A is along my shorter leg, and C is over here. So I've got my 30, my 20, and my 10. Okay, Okay, this one's an on your own problem, so pause it and try this first one on your own. Okay, let's draw our 3 triangles in here. So if I draw my small triangle first, this is point G. Here's my right angle. This is point F, and this is point D. And this side length is X, and this side length is 6. My middle-sized triangle, here would be my right angle again. This would be point D. This would be an X. That's the length of that side. This point's point F. This is point E, and then my hypotenuse would be 8. And then to draw my third triangle here, it's my right angle. So up here we'd have point G, over down here we'd have point D, and over here would be point E. And I know all 3 side lengths. This one's 6, this is 8, and this one is 10. So step 2, find the value of X. We could really use this big triangle with either of the 2 smaller ones. So I'm just going to use with the smallest one. So I'll write my proportions. I've got 6 and 10 that go together. So I've got 6 over 10 equals, and I've got X and 8 that go together. So I'll have X over 8. And cross multiply here and here. So I have 10 times X equals 6 times 8. So 10x equals 48. Divide both sides by 10, and x equals 4.8. And there's my missing length. All right, the next problems here are with geometric mean. So looking at this, it says the geometric mean is the term that describes a situation where one length, either the shorter leg or the longer leg or the hypotenuse, represents different sides in 2 triangles. So like right here, this side length of x, it represents this longer leg in this triangle and the shorter leg in this triangle. So that would be an example. It says to properly solve these, you must separate the drawing into similar triangles, and I'm going to be more specific here. We must separate it into 2 similar triangles. We really only need 2 of them. And you're going to ask yourself, which 2 triangles share a side? That's what you're going to ask yourself. That's what you're going to be looking for here. So in this next example, let's try these last 2 here. Move my screen up. So we're going to use geometric mean to solve both of these. So I've got this side length of y that I need to find, and it's a part of the smallest triangle here. But then that side length of y is also a part of the largest triangle here. So since y is what they both share, when I write my geometric mean, that's what I'm going to write twice. So I'm going to write it on the top here and on the bottom over here. I could have written on the bottom and then the top. It doesn't matter. We're now going to use the other 2 sides that we know. I know this has a length of 4, so I'm going to put my 4 here. And for my blue triangle, I know this side length of 15, so that's going to go here. Now we just need to cross multiply. Y times y is y squared. 4 times 15 is 60. To solve it, we'll do the square root of both sides. So y equals, now this says simplest radical form. So 60 divided by 2 is 30. So I'm going to start with 25. 25 doesn't go into 60. 16 doesn't go into 60. 9 doesn't go into 60, but 4 goes into 60. If you divide 60 by 4, you get 15. So it's the square root of 4 times the square root of 15. The square root of 4 is actually 2 times the square root of 15. So here is my answer, 2 times the square root of 15. So pause it and try the next one. Okay, in this problem right here, we've got this small triangle that's got a length of y, and then we've also got this largest triangle that also has the length of y. So the thing I'm going to write twice is y. I'm going to write that twice. And then for my red triangle, I've got a side length of 9, so that's going to go once. For my my blue triangle, I've got a side length of 24, that needs to go here. So to solve these, we'll cross multiply. Y times y is y squared equals 9 times 24. So y squared equals 216. Take the square root of both sides. So y equals, well, 16, if you divide by 2 and then start working your way down, you'll find that 36 is the biggest perfect square that goes into it. And it's 36 times 6, so I'll do the square root of both. The square root of 36 is 6 times the square root of 6. and that's my value for y. All right, this is the end of the lesson. Make sure you have any questions. Please let me know and have a great day.